Welcome back for another episode of the 5G Guys. I'm Wayne Smith, joined by my co-host Dan McVaugh.
Hey everyone, welcome back to 5G Guys. Today we're looking into how 5G is enabling better location-based services with your cellular service, and who better to have on the show than entrepreneur and founder and CTO of Pozyx, Samuel Van de Velde. Samuel is an electrical engineer who has a very strong interest in position technology and location technology. He does a lot of product development and works on Internet of Things and machine learning. Welcome and thanks for being on.
Hey, thanks for having me.
You bet. So we've had a couple episodes in the past, but we'll refresh our listeners about the importance of location and positioning with cellular networks and maybe give them a little history. We like to do a history lesson. And I'll kick us off with that, talk a little bit about how location and positioning worked in cellular networks in the old days. And then maybe you can tell us where we're going today and what the differences are today and what the future of cellular services look like with advanced positioning capabilities. Sound good?
Yeah, sounds awesome.
So I know some of my listeners and our listeners know that Wayne and I go way back, and we both started in the industry back when it wasn't called 1G, but we refer to it as 1G back when it was all analog cellular and big flat bag phones and flip phones. And back then, there wasn't a whole lot going on with location information other than we would use location information purely by being able to identify which sector of a cell site a phone was talking on, and that sector might cover 5 miles. And so we would be able to tell that, well, that phone is somewhere in that big area covered by 5 miles. But other than that, we don't really know where it is. And we would use that information for things like surveillance. If we got a court order from a judge saying, hey, there was a crime and we need to know roughly where that phone was, we would be able to tell them it was in a basic area, which might be the size of a small city. And we would use that information also for fraud. Back in the day, you could clone analog cell phones. And so I could have a phone, and then Samuel could be a bad guy and he could clone that phone and have another phone that the network thought was my phone. And he could be somewhere else making a call. And I'd be paying him $1 a minute plus $1 a minute for long distance. And he'd be making fraudulent phone calls. So we would use that position information because we could see that I just placed a call in Denver, Colorado, and 30 seconds later, Samuel placed a call in Belgium, and that's not possible technically to be in two places at the same time so far apart. So that's really about the basics in the early days of the way we could do location positioning and how we would use it. And then as we advanced into digital 2G and 3G, we started using location-based services where we had basically effectively a transponder or beacon that was located strategically on certain cell sites, and we would do triangulation. If I made a 911 call, we would have these beacons on several different cell sites that would triangulate. They could approximate my location and try to get emergency responders to my location. And then eventually, uh, global positioning services became a capability in our phones, and all of our phones had a GPS receiver on them. And that was probably the biggest advancement in location services, because now if I made a 911 call or had other applications I wanted to use, like Google Maps or what have you, I now had very accurate positioning data based on GPS on my phone, just like I used to have on my other GPS devices I might have used for outdoor enthusiasts or what have you. So that kind of is the history of how we've come over the last 20 to 30 years with positioning and its impact on cellular and cellular data networks. And that kind of brings us to today with the advancement of 4G and 5G. And that kind of starts to eliminate my knowledge of the subject and why we wanted to have Samuel on the show, because this is what he does. And so, Samuel, give us an update on, based on the history I've given, what things have advanced since then and what's behind it.
Yeah, I think it's only starting from 5G that positioning is becoming an important piece of the cellular technology. I think before it was the 911, being able to locate emergency calls, that was the big use case. But now it's really transitioning into a lot of use cases more for industry, and that simply requires higher accuracy. And that's why throughout 5G, with the different releases, they are gradually reducing the target accuracy that they want to achieve. So with vanilla 5G, I would say, the first release, it's still targeting at about 50 meters, but then it is coming down to 10 meters, 1 meter, half a meter, and when we're talking more about 5G advanced, they even want to go up to a few centimeters. And it's difficult to now say, okay, this is the application for that. In fact, you have a full matrix of the accuracy and then what type of application that now enables. And so they try to improve the accuracy such that more and more applications can become available. The 911 emergency call is still a strong driver because they also there want to make it more accurate than it was ever before. But we see that mostly it's the industrial use cases that are really driving this, the industrial IoT that is driving the improved accuracy here.
Got it. And I know, like in prior generations, and as we came into 4G and now 5G, one of the big advancements that we're seeing in the US is specifically around emergency services. Location used to be two-dimensional, X and Y, so we could locate on a map where somebody. But I know there's been some advancements in the US around 911 services where there's some attempts to also add the third dimension of height. So if I was on the 30th floor of a high-rise building and made a 911 call, that first responders might actually know, well, I'm not just at that building, but I might be closer to 30 stories up and be able to more quickly get to where I'm at. But the reason I bring that up is that's a cool advancement, but it brings into view the fact that oftentimes our users are indoors and GPS doesn't always work well indoors. And my history with location based services is dependency on GPS. Tell me what's going on with 5G that and the work that you guys are doing that addresses that issue and that dilemma of being in a building.
Yeah. So I think today, in terms of asset tracking, you have two kind of worlds. One is the outdoor world, and then is the indoor world. And outdoor, obviously, you have GPS, and there the cellular network also plays an important role. Not so much to position the asset, but rather to then communicate the location of that asset over the cellular network to some cloud application or something. That's one of the biggest use cases for outdoor GPS tracking using narrowband IoT, for example, to have very low power, low cost devices for outdoor GPS tracking. Now, these devices, they stop working once you go inside, or at least the GPS stop working. What you have today is then devices that then pack other technologies inside that can then do Wi-Fi positioning or Bluetooth positioning or ultra wideband, and then also maybe send this data over the cellular network over to some application that can use it. But it's then almost like a mix of all these different technologies together. And on the indoor side, you always require to have infrastructure. For Wi-Fi, which is not very accurate for positioning, but you can use your Wi-Fi access points. But if you want to go more accurate, so I'm saying a couple of meters or sub-meter, then you have to start installing dedicated infrastructure most of the time. So with Bluetooth or ultra wideband, you have to install anchors or an infrastructure that can, again, triangulate your location if you're inside, and then use that location for some application. So it's really two worlds, and outdoor, you don't need infrastructure except maybe a cellular network to communicate the location. Indoor, you don't need cellular network, but then you need the infrastructure as well. And I think, today you already have a lot of applications for both of them. But what 5G is now trying to do is combine these two worlds with a single technology. So you don't have to use this mix of different technologies, but just only use 5G to locate your assets outdoor and indoor very seamlessly. That's the goal, and that is getting a lot of people very excited today.
There's been a lot of talk lately, and you've seen it on socials in the news where folks are using their iPhone to locate them in emergency situations with no coverage, using GPS to save their lives. It's been a new feature. So with 5G, is it because the spectrum is so much wider that you're able to use 5G as a more location medium, or what is it about specifically about 5G?
Well, it's a combination of things. Well, first of all, you have a lot of spectrum, and you
Okay.
also have it sometimes in the lower bands. You have you have signals that can go over a long distance, and so for location with 5G, you would still need your infrastructure, being your base stations. And if you want to do even indoor positioning, probably you will also have to have some indoor base stations. But because you can have these low band frequencies, these signals can travel quite far and even pass through buildings or parts of buildings. And this reduces the amount of infrastructure that you would need to cover such a thing. So that's definitely a benefit of 5G. There's one nuance, of course, that I have to make. That's true, but these low bands, then they do not offer the highest accuracies. If you want the higher accuracies um, of sub 1 meter or even centimeters, then you're also almost obliged to use more the high frequencies in 5G, like the millimeter wave. And that then has the drawback that, okay, it does not go very far. It gets blocked almost by a simple wall. I think there's definitely a benefit of 5G that one technology can do a lot of things, but there's one thing to pay attention to is that within 5G you also have so many variations that it's sometimes not correct to just say this is 5G technology. No, it also depends on in which are you on millimeter wave or on the low frequency bands and things like that.
Samuel, is it also though that 5G as a standard itself actually has location positioning as part of the technology standard, whereas in 2G, 3G, the location services weren't embedded in the wireless technology standard itself. They were done by a higher level application that was independent from your cellular phone and the cellular network. Whereas now with 5G, it's an integrated technical capability within the technology standard. Is that correct?
Definitely. And I would say it's almost wired to have that to be able to achieve these kind of performances. And if you see what they're actually doing, they're actually using a lot of the techniques and the things that now other technologies are doing already, but they're just integrating this into 5G. For example, the triangulation, that's widely used, but also you have time difference of arrival. It's another approach where all of your base stations are highly synchronized, and then you're just measuring the difference in time when a signal arrives. And that's something that requires very tight time synchronization between your infrastructure. So that's something that ultra wideband, for example, uses quite heavily. That's a technology that can achieve 10 to 30 centimeters of accuracy indoors, and 5G is using a bit the same approach to be able to do that as well.
And I think the other thing too, which we've talked about in past episodes, is with the advent of 4G LTE, we basically saw a universal technology standard implemented worldwide. Whereas prior in 2G and 3G, we had three, four different technology standards. So if I was in the US, I would be on one technology standard. And if I came to visit you in Belgium, I might be on a different technology standard. So now my device wouldn't even work. Whereas now, because we're on universal technology standards with 4G and now 5G, that's got to also be a big plus in terms of allowing these types of services and applications to work.
Yeah, yes, definitely. But one thing that is important is that these capabilities are typically not enabled by default. So your cellular network has to support this, of course. The infrastructure also has to support this. So that is going to be a challenge, of course. And I don't know if it will ever happen that you will have seamless positioning coverage everywhere, because it might be that some telecom providers choose not to cover certain areas for positioning, for example. or it could be that it falls back to a very crude positioning, back to several tens of meters or 50 meters in certain areas, and then in areas where they do seem or think is valuable, or for example for more private 5G networks, there you can then really set up your hardware, your infrastructure to have this very high accurate station. But it will depend, and time will tell if it will become a seamless capability of the 5G and 6G later.
You mentioned the ultra wideband, which I'm not sure here in the States it has taken as much, like that was out of the gate, the technology. But now we're moving more into the different lower bands in order to get 5G out to the masses. Some with FWA, running on 5G. Do you think that, and I'm not sure about Europe, but is ultra wideband more frequently used there? Millimeter wave?
That's a very funny thing to say, because ultra wideband, the one that I was referring to, is actually something completely different than what you're referring to. In the US, I think it's Verizon. They labeled or marketed part of their 5G as ultra wideband, meaning that you just have very big frequency bands that you can use. But ultra wideband, the technology as such, is actually a completely different technology that has nothing to do with with 5G.
Wow. Okay.
It's also a wireless technology. It's in your phone actually, like the Apple has it in their phone. They're using to find your keys, for example, and it's so accurate that you can find them even when they're like stuck under the sofa or something. But it has nothing to do with 5G, so that's maybe some clarification there.
That's a good clarification. In the U.S. market, the marketers outpaced the technology for sure, right? And they chose whatever name they needed to, but that's a good clarification.
This episode of 5G Guys is brought to you by Vertex Innovations. For almost 20 years, Vertex has been building the nation's wireless and broadband networks. Providing project management, network engineering, and construction oversight are just some of the ways Vertex helps its clients. So if you're in need of a partner to help you with your wireless network designs, construction, implementation, or operations, reach out to Vertex. You can find them at vertex-us.com.
So let's talk about indoor. So Pozyx, as I understand it, you guys do a lot of application focus that is specific to not necessarily exclusively indoor, but a lot of those use cases tend to be indoor. Tell us a little bit about what some of those use cases look like. You've talked a lot about industry. Give us some specific examples of types of applications you guys have been working on.
Yeah. So I think one very big one where we're working together with a larger partner is in agriculture for tracking cows. And we don't know a lot about cows, so we just provide the location technology. Small ear tracker that you have that you put on the cow. It's for dairy cows. And then it's our partner, which is a major company in this field. They then use this location data really to predict the behavior of the animal and to know when it is getting sick or when it has to be inseminated. So this is a quite big application today. Every month, about 10,000 or more cows are being equipped with these trackers. Definitely in the US, you have some very big farms with a lot of cows. So this is used, and for that application, it's actually using ultra wideband technology, not the 5G marketed one. So, but there, I think that one demonstrates very well what the high accuracy can do. The cows are being located with 10 to 30 centimeters of accuracy, and you might think, why on earth is this required? But knowing where the cow is doesn't really matter as much. I think what matters is that you know where the cow is. And for example, cows, they walk around and then they eat. And when they're eating, they're sticking their head through a fence, and then you have like all the hay on the ground, and then they're eating. And because you can very accurately know their location or the location of their head, you know that they're sticking it out through the fence and that they are in this feeding area. So you know that they are feeding. And then you know how many times are they feeding in a day, how much time are they spending feeding. And apparently these are very good markers that you can then use in some kind of AI algorithm to determine the health and the behavior of that animal. So feeding is one thing, but you can then also know drinking, or it's laying down, or it's playing, or it's getting milked. And all of these statistics you can use to really, know a lot about this cow. This cow doesn't have any privacy. We know everything about it. And apparently this is helping the farmers tremendously, definitely for insemination. I didn't know. I feel very ashamed, but I didn't know that a cow has to be pregnant first before it gives milk. So this has to happen a few times in the lifetime of the cow. But you have to inseminate it right on the right time, because otherwise, you're just getting the veterinarian for nothing and taking all the time. And so now, by knowing the cow's behavior, you can know very accurately when do you have to inseminate her. And that's the business case for that is very big.
So it's what I love about the story you're telling with this use case is it's more than just the location information. It's the convergence of all of these advanced technologies happening at the same time. It's high accuracy of location combined with AI, combined with big data analytics. So all of these things converging at the same time create this ability to do all of these advanced solutions, which is, I think, a great story and a big part of what Wayne and I talk a lot about is you can't look at all these technology advances in a vacuum. Like you have to think about them in the larger ecosystem of telecommunications and technology and how they all are leveraged together. So that's a really great story.
Yeah. And so I think from our side, we started out as a company as a technology provider on, in our case, ultra wideband localization, and build a system around that. But gradually, we also learned that you have to do something with that location data. What are you going to do with that? And that's when we started building more a software solution. And that software solution, it can grab location data from ultra wideband, but also from 5G locations, from GPS locations, and then it does all kind of things. We focus mostly on manufacturing and distribution, because we see a lot of value in tracking forklifts, tracking industrial assets, equipment, and even operators. So we focus a lot on that. So we're becoming more technology agnostic, because we assume that we can get the location, whether it's ultra wideband or 5G doesn't really matter for us anymore.
But so this is fairly new, definitely in the iPhone, since 2019 that they enabled those services. And that probably goes back to the chip that they're using in the modem inside the phone.
Ultra wideband itself, it exists already for some time, but then it was really used to use its strengths, being indoor positioning or accurate ranging and accurate timing. So we see this technology now heavily used in consumer smartphones, but also in cars, where cars would automatically unlock when you come close, and doing this in a secure way. And then in industry, there are a massive amount of applications. I think one other one that really speaks to the imagination is one we're doing with a large e-commerce system. And there we're tracking all these different carts and cages, and they put a lot of goods in them, and then they go in the truck, and then they're transported to some other location. So now there's still a lot of manual work to fetch the cages, put them on the right dock, and then put them in the truck. And obviously, you want to automate that with AGVs, but the problem with these AGVs is they don't know where the cart is or where the cage is that they need to pick up, or if it's coming out of the truck, the system or an AGV will not know which one is where and where you have to pick it up. So there, accuracy is very important. 10, 20, 30 centimeters is really important, that the AGV can get to the right cage, get underneath there, pick it up, and then get it into a completely autonomous flow for the rest of the distribution center. And again, this can be done with ultra wideband, but this is also one of the things that 5G is aiming at. And that's why the 5G Advanced is aiming at doing this with a few centimeters, because then now you can track your AGVs, your carts, and really go to a factory of the future where everything is automated. And as long as you have things that are not automated and you don't know where they are, your process could stop, and you would still have to have a manual person picking something and putting it on the robot, for example, which is ludicrous.
What does the acronym AGV stand for?
Yeah, sorry. AGV is an automated guided vehicle, so small robots and you have these robots that they're like these very flat things on some wheels, and they can really go underneath the cage and lift it up and then move it to another location, drop it down, and then the little robot will move again.
Really
Yeah.
cool. I've seen videos, and I think you can actually go tour Amazon distribution centers where you can see all of these distribution centers that are literally dark because there's no lights or air conditioning needed, because all it is these AGVs running around, moving packages around and automating that whole system. It's really cool.
Yeah. And like I said, we're working with a big e-commerce company. But the thing is that if you're in a system where nothing ever leaves and you pick something up and you drop it down, it doesn't matter. But as soon as your cages go outside because they're going in a truck,
Mm-hmm.
you have this disconnect and you don't know where it is anymore.
Mm-hmm.
So that's why, I think it's a very nice application of accurate location and what it could do.
Yeah, there's a similar application I've heard about where produce might come from another country. Let's say it's coming from Mexico over a barge to the United States, and they're in these large metal containers. It might be tomatoes, and those tomatoes are picked off the vine before they're ripe. And there's a certain chemical that can be used in the air to trigger the tomato to start ripening. So as that barge gets near the port in, let's say, Los Angeles, location information is automatically detected, and the chemicals released into the air of the cargo ship to then start the ripening process, so that tomato arrives at your grocery store in the perfect ripe condition. Like, amazing, the kinds of things that this is being used for.
Yeah, I'm learning now even more about agriculture today.
Yeah,
No, but
it is super fascinating.
but I would say indeed in the global supply chain, food is a very important thing, and more we're trying to track and trace food. I think in the US there's even legislation coming to improve the track and trace of the food and the health of the food. And location will always play an important role in that, because it tells you where it has been, how long it has been somewhere, which stops did it make, and you can then trace it really back to its origin. So there's a lot of use cases. I don't say that this is something that 5G is going to solve. I think location technology as a whole, 5G is just, or 5G positioning is just, another, I would say, bullet in the gun to solve this, or these kind of these problems.
All of it's coming together because with so much data that you're collecting from the location based, you definitely need tools like AI and machine learning to understand what is actually happening. So, how do you talk to your customers about that? How do they already know the power of the data that the location based is bringing, or do you guys present your businesses with a business case on the value of it?
We can do accurate positioning, accurate indoor positioning. And obviously, what you attract are people that have some kind of an idea of what to do with that already. So I would say the early adopters, the company that we worked with, the animals, I would say they are really innovators. They had a very innovative idea, and they knew we need indoor location and accurate location to solve that problem. But then how do you scale that further? Because there are so many people that don't know what to do with it. So then you have to switch it a bit around and really more explain about the problems that you're solving. And that was for us a learning as well, because initially we said we can do sports tracking, we can track athletes on the pitch, what they're doing, which you can, but then obviously you need an application to do something with that data. Or you could use it in fairs, in an expo. You could track the visitors, how much time they're spending in each stand, and how are the streams going. And as a stand holder, you would finally know, okay, how many people are actually passing by my stand, and is it worth investing in going to this fair or not? But again, location data is one thing, but then how do you do that and how do you present that? So for us, we made the decision to really go into manufacturing and distribution, to really focus on things that can improve the productivity. And we mostly focus on forklift tracking, operator tracking, and then on the returnable packaging. So these are some of the things that we definitely focus on. And what we then say is that, okay, sometimes I start saying with this story about the cow that it has zero privacy, and then I change the cow with a forklift, and now you know exactly what your forklift was doing the entire day. Maybe, and I think that's what a lot of companies are still struggling with. They have this big fleet of forklifts, but half of them are just standing still, or they're moving around, but they're not carrying anything. So how would you know that? How would you measure that? And that's where location can help, and that kind of value that we try to bring. Because everybody says about location, it's nice, but then what do I do with it?
Thank you so much, Samuel, for being a guest. So if you guys want to connect with Samuel and his company Pozyx, pozyx.io is the web address. Is that right?
Perfect.
Yeah. Any other ways that people can connect with you guys or see what you have going on?
On LinkedIn, we're very active to share about use cases and also the different kind of technology. So not only about ultra wideband, but also GPS, 5G. Yeah, we're very active bloggers, and we share it on LinkedIn as well.
We'll put links to your LinkedIn as well as your website and any other sources that listeners can connect with you guys in the show notes. Thanks, Samuel.
All right. Thanks.
Yeah, thanks, Samuel.
Thanks for listening to the 5G Guys. For more resources and to connect with Dan and Wayne, check out their website at 5gguys.com. If you enjoyed this episode, be sure to hit that follow button and share this episode with your friends and family.